Hey class, welcome to lesson 4.6, transformations of exponentials. I think it's going to be 4.6a actually. Next day we'll be doing a mapping sequence. So there'll be 2 days we'll be spending on transformation. So if you want to just add an a in there, that would be helpful. All right, so for today, in order to, again, discover some different aspects of exponentials, we're going to be using the graphing calculator to help us. I would recommend that you grab 3 different colored pencil crayons or 3 different colors so that we can show this stuff, especially these separate graphs. All right. So taking a look, hopefully you've got your 3 different colored pencil crayons. We're going to go to the graphing calculator. So again, I'm going to be flipping back and forth between the lesson and the graphing calculator. So I'm going to flip to the graphing calculator. It says to take the window and to reset the window. So we're going to go -3, enter 3, enter 1, enter 5. Sorry, my fault, -5, and then 10. And 1 and 1. So now that I've got my graphing calculator set up in terms of my window, I'm then going to enter 3 equations in. So we're going to compare 3. So the first thing in y1, we're going to go 2 to the x. Okay. The second equation is going to be 3 to the x. And I'm going to change that to a solid line. Just going to hit enter once. It's going to be a thicker line to make it bold. Okay. And then I'm going to go to the last one. I'm just going to change it to what I call the whirligig, which is that one. And then I'm going to change that to 4 to the x. All right. So here we go. Let's graph these folks and see what we get. Okay. So when I press graph, here comes my first expression. Okay. That's y equals 2 to the x. Okay. Y equals 3 to the x is a little steeper. And coming in with my whirligig on the end here is going to be y equals 4 to the x. Okay. So notice the shape is changing here, folks. The rate of change is getting higher as we increase the base. So let's go back to our lesson and make some conclusions. First of all, let's do a quick sketch. So if I let the first one be my y equals 2 to the x, I'll color code it here. Okay. The next one I'll let be y equals 3 to the x. Okay. And the last one that we'll do y equals 4 to the x. All right, so now that we've sketched our 3 graphs here, it says to compare the 3 graphs. So what is similar about these graphs? Well, first of all, you notice as they go from left to right, they're all increasing, so we call that an exponential growth. So they're all exponential growth. Okay. We also know that there's an asymptote here, folks. So it's the same asymptote, which is y equals 0 asymptote. Okay. Or you can just say x-axis if you want. Okay. And we also notice that there's a common point here, ladies and gentlemen. They all go through the point or the y-intercept of 1. Okay. So y-intercept equals 1. So down below here it says the graphs have 1 point that they all pass through. We might as well do that since we're there. 0 and 1, which is your y-intercept. What are the differences here, folks? You notice that when they're increasing at different rates. So we have that rate of change is different. Therefore, we have different graphs. Okay, good. Let's keep moving down along here, see what we have. It says press trace and the we got the wrong arrow here. My fault. Let's fix that. Let's press that arrow button. Okay, so we go to the right and watch what happens to the x and y values. Okay, so let's go to the graph and do that. So if I press my trace and then this button, As x increases, what's happening to y, guys? It's also increasing. So let's put that in our graph, or in our handout, sorry. As the x value gets larger, or increases, that means it gets larger, the y value also gets larger. Okay. Do the y values ever become 0 or negative? Explain. And does the graph ever cross the x-axis? Explain. These are actually the same question, just worded differently, so we can answer them together. And what do you think here, guys? Well, the answer is no. And hopefully you've figured out, because we have the asymptote at y equals 0. Okay. Good. Let's do the other half here of the graph. So we're going to move all the way up for our, sorry, half of our handout. My apologies. So what we're going to do now is we're going to compare three graphs. But what's different now is looking at our bases. We have 1/2, 1/3, and 1/4. All right, so let's go to the graphing calculator and plug those in. So I'm going to go y equals. I'm going to go bracket 1 divided by 2 bracket hat x. I'm going to go down and I'm going to go bracket 1 divided by 3 bracket hat x. And then I go bracket 1 divided by 4 hat x. Okay, so is everybody ready to see the trend here? Let's take a look. So here's the first one, which is 1/2, 1/3, and 1/4. Okay. Notice again, the rate of change is different, which produces other graphs, or different graphs. Going back to our handout, so let's just quickly draw them. So this was 1/2 the x. This was 1/3. And this was 1/4. Okay. All right, so we sketched the three graphs. Let's compare the three graphs. What's the same about all of them? Well, they're all decreasing as we go from left to right, so we say all exponential decay. Okay. We also notice that there's the same asymptote, so y equals 0 asymptote. And we also notice that there's still that common y-intercept, where y equals 1, which answers that question down below. They all have that common point, 0, 1. That will change when we get to the next page of our investigation, next full page of investigation, okay? All right, taking a look at the differences. Again, we have a different rate of change, and that's creating different graphs. All right, let's finish the questions here below. So as we press the trace value and go to the right, gotta press trace and go to the right. Sorry, second trace. To get on, oh, sorry, that's what's the problem. Let's try that again. Just trace, and I go to the right. My fault, not second trace. So as we go from left to right, as we increase the x, or as the x gets larger, the y gets smaller. Okay? So as the x values get larger, the y values get smaller. Okay? And again, we can answer these two questions. They become the same answer. So no, because asymptote at y equals 0. Good. All right, let's move on to some other examples. So in these two cases, folks, the only difference has been the rate of change. We're going to add another element to it that's going to change also maybe a translation or a transformation on the second page. All right. So taking a look at our next page, folks, we're taking a look at the table of values and what to do for this. So it's easiest, I find, to do this in the graphing calculator to get your table values and then plug it in here. So let's go back and do that. So the two equations we're looking for is 2 to the x and 3 to the x. So let's go to y equals. We're going to go clear down arrow, clear down arrow. And here we go. So let's plug that in, 2 to the x and 3 to the x. All right, so we can graph it just to see. Here comes 2 to the x. And we learned from last page that 3 to the x is going to make it a little steeper or a little increased rate of change. Okay, now to get our tables, we go second and table. And there's our values. Now notice we've got decimals here. We're going to use fractions to help us. So I'm going to start at the bottom, okay, when I transfer it over. So I'm going to start with 8. And then it's going to be 4, and it's going to be 2 and 1. What's happening each time, folks? It's being halved as I go from left or from the bottom to the top. So half of 1 is going to be 1/2, 1/2 of 1/2 is going to be 1/4, and 1/2 of 1/4 is going to be 1/8. Okay? Likewise, when I look at 3 to the x, starts with 27, it becomes it becomes 9, and then it's going to become 3. So in each time, it's getting a third, okay? So it's going to be 1/3, 1/9, and 1/27. Obviously, you can't plot all of these on the graph, but we can plot some of them. So let's use the red graph here, okay? So again, we've got the common point, 0 and 1. And then I'm going to do my whole numbers first. So 1 to 2. And 2 to 4, and 3 to 8. And again, when I'm going the other way, I'm going to go half the distance, half the distance, half the distance. All right, taking a look at our second graph. Again, I start at 0, 1. That's a common point here. But when I go to 1, 3, that's a key point to remember. That tells you that it's a triple factor as opposed to a double factor. So if you're given just an equation, you want to look at that key point where x equals 1. All right, that'll give you your base if you just have a graph. Okay, keep moving on here. I can do 2 and, sorry, my fault. I can do 2 and 9. What do I have here? 2 and 9, that's right. So 9 is just off the graph here. All right, and this time when I do this, folks, it's 1/3, so it's dropping way down. So the steeper the rate of change on the positive sign, the more quickly or rapidly it goes towards the asymptote. So you'll see a quick overlap there. All right. Okay. So just remember, both these cases are a growth. Okay. And the larger the larger the base, increases faster, right? The large base increases faster. Okay, let's take a look at the other two and compare these two graphs. Okay. So we go to our graphing calculator, we plug them in. So 1 divided by 2 to the x, and 1/3 at x. Okay, let's graph these two. Sorry, my computer's a little off, sorry. Okay, there's the 1/2 x to the x, and there's the 1/3 to the x. Okay, let's use the table. So go second graph. Okay, plug the values in. What you notice, folks, is it's the opposite effect of what we had from example 1. Okay, so the values are what were on the bottom are now on the top. So you're going to go 8, 4, 2, 1, 1/2, 1/4, 1/8. Likewise, you're going to go for the 1/3. It's going to be 27, 9, 3, 1, 1/3, 1/9, and 1/27. All right. I apologize. I should do that in a different color. Let me just erase that so that you can tell on my answer key what color is the different for each graph. Okay, let's plot these. So again, we still have the common point 0 and 1, but when I go -1, it's 2. When I go -2, it's 4, and -3, it's 8. And again, it's going to be half each time. Looking at our 1/3 to the power of x, again, we start here, and then -1 is 3, -2 is 9, and then we're going to do 1/3 here, so it goes down lower. Yeah, good. All right, let's summarize the properties. This would be a good thing to have star and say study for test, as we're going to develop even further on in the next page. So, properties of graphs in y equals b to the x form. When b is greater than 0, the graph curves up to the right. So the graph shows an exponential growth. I apologize, folks. I forgot to summarize these graphs here. Can we step back for a second? So these cases, they're decreasing, so we call those a decay. Okay? And the thing is here, the smaller the base, the steeper the graph. All right. Good. Okay, let's keep going here. So if our base is between 0 and 1, the graph curves curves down, okay, to the right. So the graph shows an exponential decay. Okay, the graph of y equals b to the x always passes through the point 0, 1, because the exponent value at this point is where exponent of 0, and anything with an exponent of 0 is 1. Okay? All right, the y-intercept of this graph is 1, and the graph gets very close to the x-axis, but never crosses it. The x-axis is called an asymptote. So you might have had "and" cut off because your hole punch there. All right. Oh, my fault. That's an E on the end. Asymptote. Okay. This graph, notice folks, does not have any max or min values. Reason why is because it continues growing or increasing or decreasing. That's because there is no vertex, like we do have in a quadratic. All right, so in class, folks, we're going to complete investigation handout, which we're just going to keep doing right now. And then for homework, you're going to do page 251, numbers 1 to 4. So let's take a look at further extending our transformations of the exponential functions. Okay, so back with our graphing calculator, we're going to reset it, and then we're going to add the following following three equations in. Notice what's different now is we're adding a number onto the end. Okay, we're going to keep the base the same and see what happens. Okay, so let's go to our graphing calculator and do that. First thing we need to do is change our window. I'll just clear this out. put a window. They say to go to negative 10 to 10. Oops, sorry. Negative 10. Then to 10. Then to 1. Then to negative 100. It's alright. I'm having trouble pushing my buttons today, guys. Alright, negative 100 to 100. And we'll leave the rest the same. That's going to stay as 100. Okay, I think we're good now. All right, let's go to the equations, clear out them because we're just finishing them from last page. So let's put in 2 to the x for our first one. And then we're going to go 2 to the x, and we're going to add 10. And then we're going to go to the third one, which is 2 to the x. And then we're going to subtract 10. I think my computer's delayed a bit. Sorry, guys. Let's try that again. 2 to the x, subtract 10. Good. All right. We could change the colors or change the thickness of the lines, but we'll just watch in order to see where they go, okay? So let's graph it and see what happens. Here comes the first one. Okay. Second one, notice what's happened. The asymptote has shifted up. And the third one, notice that the asymptote has shifted down. All right. So let's transfer that to our handout now. So again, if I keep the first one the same, you know that it scoots along the x-axis and comes back up. The second one we noticed was raised up 10, so the asymptote was here and then scooted back up. And the last one was decreased by 10, so it dropped 10. Okay? So basically what we learned here is that we look at f at x. It has, oh, I apologize, let me fix the right colors here. So for f at x, ladies and gentlemen, it has a y-intercept of what? Same as last page, y-intercept of 1. Why is that? Because we had the asymptote of y equals 0. Okay, moving along to g at x. So g at x has a y-intercept of 11. If you're not sure, you could just plug the. I'll go and show you in just 1 second after I've done this. Okay, so that's y equals 10 is your asymptote there. And the last one, which is h at x, it has a y-intercept of -9. Why is that? Because we have an asymptote where y equals -10. So what have we identified here? Hopefully we've identified the letter C. Okay, that's your translation either up or down. Okay, and state the domain and range of g at x and h at x. Okay, so basically it's going to be domain is such that x belongs to set of real numbers, whereas the range is y belongs to set of real numbers such that y is greater than c. That's okay, ladies and gentlemen, when it's not been reflected, okay? So the range will always depend upon the y value when it's affected by c, but sometimes it could be less than when we do some flipping, okay? Just quickly show you, if you can't remember how we do the intercept, ladies and gentlemen, if you go to the calculator and say we highlight my second, let's try and trace maybe that one, for example. We want to find that y-intercept. You go second, calculate. Where do you find the y-intercept? When x equals 0. So you go value where x equals 0, press enter, and that's going to give you the y-intercept. If I scroll down to my Next one, that's where you're going to get -9. And if I go up, that's where you're going to get your 11, depending on what equation you're looking at. All right, let's go back to the handout here. We're going to graph 3 more. Notice now the change is no longer at the end of the expression. It's up with the exponent that's being changed. So you're going to need to put some brackets in when we graph these, okay? So I'm going to go back. Y equals 2 to the x. That's what we're going to leave for my f at x. For g at x, we're going to go 2 hat, opening bracket, x plus 3, closing bracket. Then for the next one, we're going to go 2 hat, bracket, opening bracket, x minus 3, closing bracket. All right, everybody ready to watch these and see what happens here? Okay, let's do the graph here. So there's your regular one. Okay. There's the +3. And there's the -3. So what do you notice, folks? They look like they're the same graph. They just look like they've been shifted either left or right. Okay? So let's go back and make some statements and draw those in. Okay? So what do we notice? I'll just color code these better. So we know that our 2 to the x, our 2 to the x had our y-intercept right here. Okay? And then the +3, it actually shifted 3 this way. Okay? And then the last one, h at x, it actually shifted this way. Okay? So basically when it says to describe the differences between g and x and h at x compared to f at x, the y-intercept changed, okay? Okay? So it's either shifted left or shifted right, so therefore we had what's called a horizontal translation. So what letter deals with horizontal translation, folks? We have the D. Okay? So how do we do the domain and range? Again, the domain is such that x belongs to a set of real numbers, whereas the range is y belongs to a set of real numbers such that y is greater than or equal to 0. Good. All right, so far in this investigation, we've discovered C, and again, that's your horizontal, your vertical translation up or down. Now we've done D, which is your horizontal translation left and right. Now we got to deal with some other aspects that can affect transformations. So let's go to our graphing calculator and plug these ones in, folks. Okay, go to y equals, clear it out. Clear. Here we go. So the first graph we need, oh, I guess I didn't need to erase that, my fault. Okay. My graph's doing funny things for me on my smartboard, so I apologize. If it looks like it's flipping, it actually is. Sometimes it has a mind of its own, right, guys? That was an odd one. Okay, here we go. I think we're back on track here. And the third one is going to be 1 divided by 3. All right. Let's take a look at what these graphs look like, ladies and gentlemen. So here's our one to compare it with. Third one hopefully is coming. Good. All right. So we've got something new here, something different. Okay. So let's take a look at transferring that over. Just going to press graph one more time just to see if go to y equals for a second. just so you see what happens. Oh, just give me 1 second. So I got to clear these for 1 sec. Okay, now we're going to try, we're going to go to graph, nothing should appear. Let's go to y equals. I'm just going to highlight the equal signs again so we can see. And this is a point where if you ever want to just isolate one of them, you can just tell the computer, I'm going to graph all the ones that are highlighted. So again, here we go. Here's the 2 to the x. Here comes 3 times 2 to the x. Okay. And here comes the 1/3. Okay. Go to my graph. And let's put those down. So first one is kind of like this. Second one with the 3 in front kind of went like that. And then the third one, which was 1/3, kind of goes like that. All right. So taking a look, ladies and gentlemen, we've learned about something else here. What's happening is that they're all at the same point here, but just is affecting our vertical stretch. It's A, which is the letter out front. So I'm going to flip the page here, and we're going to talk about that. So the y-intercepts have changed. The y-intercepts have changed slightly. Okay. Because y equals A. All right. So what do we have here, folks? We have a vertical stretch. Okay. So you could have a stretch of 1/3, or we have a compress if we're looking at the third one, which was h at x, has a compression of 1/3. Okay. So just to double check that, we have the g at x giving us a stretch of 3, and the h at x giving us a compression of 1/3. So what letter have we identified? A. Does A have any impact on our range and domain? No, it does not. The only letter so far that deals with that is in the range part is C. Now, we could argue that A does possibly have an impact, and that's going to be if A is negative. In these cases, they weren't, okay? All right, let's deal with one more letter. What letter do we still need to deal with, ladies and gentlemen? In this last example, we're going to be dealing with the letter K. Okay? All right. Let's take a look at our second last example 4, graph the following function. So we'll go to our graphing calculator. This is a long lesson, I know, but it's of good value because we're going to arrive at our new transformation function equation. Okay? So the first one is y equals 2 to the x. The second one is negative 2 to the x. I'm going to delete that and delete that. And the third one is going to be 2 to the negative x. My fault. Let me fix that. Hat negative x. Let me just double check this, folks, before I graph this. I've got 2 to the x. Oh, I apologize, folks. Please back the truck up. I was looking at question 5 instead of question 4. So again, I apologize. Let's go back up here and fix these. Okay, so that should be y equals y to the 3x. Sorry, guys, I got distracted there. Back on track now, though. Y hat, help me out. Is it 1/3 x? I think it's 1/3. I just can't read on my notes. Let me just flip back for a sec. Sorry. Yeah, it's 1/3. Good. Okay. Sorry. See, it's lagging. You see that? All right, so 1/3 times x, that should work. All right, are we ready to take a look at these graphs? All right. So here's our first one, which is y equals 2 to the x. There's something wrong with that one. We've got to go back and take a look at that one, because that's a linear one. All right, let's go back, folks. Do you know what I see the problem here, folks? I forgot to adjust the window. So let's go back and check my equations. I have those done, I think, correctly. Let's just see if when I change the window, if it affects it. I apologize. Okay, let's try them now and see if this helps. Still looking like I've got that linear line here. So it's the second one I'm having trouble with by the looks of it. Maybe I should just put this in brackets. I think I should put this in brackets. 3x. That's my problem right there, guys. Now we should be fine. There's the first one. Here's the second one. And here comes the third one. Okay, let's transfer those over. Okay. All right, so here's my first one. Use black. Okay, our second one went really, really steep. And our third one went kind of wide on us. All right. Okay, so describe the differences between here. Well, we had a horizontal compression and a stretch. Okay, so let's write that in. So we had horizontal compression. Thanks for staying with me, guys, because I know this is a long lesson. 1/3. Or we had a stretch to the factor of 3, right? Okay, so what have we identified, folks? We've identified the letter K. Again, our domain and range still aren't impacted by the K. So the domain is x belongs to a set of real numbers. The range is such that y belongs to a set of real numbers, such that y has to be greater than 0 in this case. All right, folks, last group to graph. We can get through this. Here we go. All right, so the first one is y equals 2 to the x. Second one is negative 2 to the x. And the third one shows 2 to the negative x. All right. Let's see if I have to change the window or change the window again. I do. Thank you. So looking at that, I'm going to go negative 10. Enter. 10. Enter. That looks good. Okay, let's graph these, guys. So here comes the first one. That's usually the same as what we had before. Uh-oh, what happened to the second one, guys? And the third one, they're all looking different. Huh. Let's figure out what we have here. All right. Well, the first graph, which we've been graphing all along, looks like that. Okay. The second graph is reflected that, guys. So it's a mirror image, but it's going down. And the third graph, it changes. It changes and goes this way, like that. All right, so describe the differences. Well, first of all, when we take a look at the g at x, which is in red, that has a y-intercept of -1. Therefore, it's a reflection of the x-axis. Whereas when you take a look at the h at x, it's a reflection of the y-axis. So what have we identified? Well, we identified the a value in g at x. And we identified the k value for h at x. And that dealt with doing reflections, ladies and gentlemen, okay? Now, stating the domain and range, again, things got changed here, and it depends upon your a value. So let's take a look. The domain stays the same, where x belongs to a set of real numbers. That's not going to change. But what changes here a bit is the range. So y belongs to a set of real numbers such that y can be greater than 0 when a is greater than 0, but y can be less than 0 in this case when a is less than 0. So it depends on your a value. And in this case, it's 0 because that's your value of your c. So now, ladies and gentlemen, here's the important part that we're arriving at. Now we're going to come up with an equation that has a, k, d, and c in, and apply it to exponential functions. So what we need to do is go f at x. Sorry, my fault. G at x, because f at x is going to be your parent function. So we'll go g at x equals a. That's your value of a, same as before. B, that's the new letter. K, x minus d, all up in the exponent, plus c. The thing that's new, folks, is the fact that we have a base. So we've got a numeric value that's in there, but your a, k, d, and c have the same placement with the exception that this is now up in the exponent, okay? That's why we didn't include it, folks, as part of your parent functions, because it would probably throw you off, because in every other parent function, the x is part of the base, not part of the exponent. Okay, so the only thing we want to add here is where b is the base. We're going to call that the factor when we take a look at that in a couple days. Okay, we know that domain is such that x belongs to a set of real numbers. We should also know that the asymptote will lie wherever c is, so y equals c. Okay, and so tying those in to get our range, ladies and gentlemen, which can change. The domain won't, but the range can. We're going to realize that y can be greater than or less than c. And again, that depends on your a value. It's going to be greater than if a is greater than 0, or it's going to be less than if a is less than 0. That gives you your direction of opening. All right. Thank you for staying with me, ladies and gentlemen. I know that was a struggle. I apologize for those couple errors. Have a great day, folks, and hopefully this has helped you to develop this formula and practice using the graphing calculator just to help you see what type of transformations and translations you can do. And as always, come and see me if you need some extra help. Have a great day.